All right, a little review on vocabulary. CF. Where's CF? Well, CF right here, center to the outside of the circle. That would be a radius. AB. Now notice very carefully, it's AB this way. Okay, so AB going this direction, one direction only. That would be a ray. I'm sorry, well, it is a ray, but being that it only touches at one spot here, the more specific answer would be that it is a tangent. Okay, so it is a ray, just touching one part of the circle. FB, where is FB? FB goes from one side through the center to the other side. Very important that it goes to the center. That makes it a diameter, as opposed to a chord, like EF. EF goes from one part of the circle to the other part of the circle, but not through the center, making this a chord. DF. DF goes through the circle, like so, making it a secant. And finally, BC, which is the other side of CF, from 1, making it another radius. All right, well, I screwed up when I was making this packet, and this is not example 1. This was supposed to be cut out, so enjoy doing that. I messed up. So, core concept, new formula, surface area of a sphere. So, think about a ball, okay, a tennis ball. It's got that rubber, you know, have you ever had a dog chew off the yellow part of the tennis ball? That's the covering of that rubber ball underneath. Well, the surface area is how much that yellow felt does it take to cover that rubber ball to make it into a tennis ball. The formula for that is very simple. It's 4 pi r squared. Going back to what we've been talking about all the time, what is pi r squared? That's the area of a circle. Well, the area of the circle times 4 is the surface area of that sphere. All right, so here we go. We are given the radius, so we're good to go here. So we start off with our formula, pi r squared, but don't forget that 4 there. So 4 times pi times 8 squared. So that's going to be 64 times 4. Okay? So just type in your calculator 64 times 4, and you get 256 pi inches squared. Now, even though this is a 3D object, we're just covering the outside, so it's still area, which is a square measurement. And if you multiply that out, you get 804.25 square inches. Now, on to B. It says the circumference is 12 pi feet. That's the distance around the circle there. Well, now we got to work backwards. We know circumference is 2 pi r. Well, we know, we're working backwards here, we know the circumference is 12 pi equals 2 pi r. So if we divide by 2 pi, both sides, we get the radius is 6. We're not done yet. That's just the information we needed. So this is 6 feet. So area equals 4 times pi times the radius squared. So 6 times 6 is 36. 36 times 4 is 144 pi feet squared. Now if we multiply that out, we get 452.39 feet squared. Final answer. So either one is fine. Remember, pi is the exact answer. A decimal is actually an approximation. So I just screwed up. That would have been example. No, that is example 2. Almost had them doubled up then. Example 3. This is 20.25 is the surface area. We're trying to find the diameter, so we're working backwards. So we put 20.25 over here equal to 4 pi r squared. Oh, it's not 20, sorry, it's 20.25 pi. Big difference. So I need to get r squared by itself, so I'm going to divide by 4 pi. And 4 pi. On the right side, everything cancels, except for the r squared. And here the pi's cancel. So basically I'm just doing 20.25 divided by 4. And that gives me 5.0625. And I'm not going to round this because it ends there. It's okay to deal with. And now when I take the square root of both of these, I get r equals 2.25, and that's centimeters. But that's not what the question is asking for, is it? It's asking for a diameter. So I need to double that. And hope the board works. And the diameter is double that, which is 4.5 centimeters. Okay, new concept, new formula. The volume of the sphere, filling the round object. Okay, so if you have circular like a snow globe, and you put how much water goes in that snow globe. It's similar to the surface area. We still have the 4 and the pi and the r, but this time it's cubed, and we have a 3 in the denominator. So 4/3 pi r cubed. Or another way you can write it is 4 pi r cubed divided by 3. That way when you're punching the calculator, you just do everything on top and then divide by 3 at the end. All right, find the volume. This is actually example 3. Sorry, I screwed up. So, we know the radius is 4.5. So volume is 4 pi 4.5 cubed all over 3. When I do the math, 4.5 cubed times 4 and then divide by 3, I get 121.5 pi. And of course, that's inches cubed. If I multiply it out, I get 381.7 inches cubed. And remember, if it said rounded nearest hundredth, I would actually put 70 because I need to put something in that 100 spot. Just like money, you can't throw away that spot. It'd be 70 cents. Okay, this is actually example 4. The surface area of a sphere is 324. Okay? Find the volume of the sphere. Interesting. So, first step is we need to find out the radius of this thing. Okay? So we work backwards. So there's going to be a 2-step problem. Here's our surface area equal to pi r squared, right? Sorry, 4 pi r squared. So I'm going to divide both sides by 4 pi, like we've already done. We've already done a problem just like this a few back. We're just going to have an extra step. We're basically combining the previous 2 examples. So that's going to give me 324 divided by 4, which is 81, equals r squared. Square root both sides, and I know my radius is 9. Now that I know my can't speak, sorry. Now that I know my radius, I can calculate the volume, which is simply 4 pi r cubed divided by 3. So 9 cubed times 4 divided by 3 is 972 pi, and that's centimeters cubed. Then I'm going to multiply out and get 3,053.63, that's a 3, centimeters cubed. Again, exact answer versus approximate decimal answer, rounded. And our last example, which is actually a 5, example 5, find the volume of a composite solid. Now, it might be hard to see what's going on here, but this is a cylinder with a hemisphere cut out of it. And a hemisphere is half of a sphere. So what do we do with this? Well, think about it. If we had a cylinder like we did in our previous section, and we actually had a hemisphere on top of it, we would find the volume of both and add them. Well, since this, let's call it the lid, is upside down, that means we're going to subtract the volume of the hemisphere from the volume of the cylinder. So, step by step, first we're going to find the volume of the cylinder. So, the volume of the cylinder is pi r squared h. And then we're going to subtract half the volume of a sphere, which is 4 pi r cubed divided by 3. Because remember, we only want a semi or a hemisphere. So, let's do the math. Pi r squared. We have pi, the radius is 2. So that's going to be 2 squared, and the height is also 2. Now you can do this separately or all at one time, it's up to you. Minus 1/2 4 pi 2 cubed divided by 3. And you're still really crunching them. It's just whether you want to write it separately or write it all as one problem. So 2 squared is 4 times 2 is 8. So this is 8 pi. Minus 2 cubed is 8 times 4 is 32. Half that is 16. So we end up with actually 16/3 pi. A little nasty. Okay? Well, we need to have a common denominator. So 8 is really, 8 is really 24/3, right? 24/3 minus pi, 16/3 pi. So 24 minus 16 is 8/3 pi. And again, that's going to be inches cubed. And this is kind of a weird number for 8/3 pi, but it actually ends up working out to be 8.38 inches cubed. Strange coincidence there. And that's it.